Hi, it's Mrs. Lambert here. This is the last lesson in this series of lessons on fractions, decimals and percentages. Get yourself a pencil and some paper and your practice activity from the last session. I don't know about you, but when I looked at this practice activity and started to work it out, I realised that Molly's long distance walk was incredibly long. So let's have a look at the information. She's walked 14 kilometres, and this is just 4% of the total distance. Did you draw a bar model, or a double number line, or a ratio chart? I drew a ratio chart, so let's have a look at that together. So 4% of the long distance walk equals 14 kilometres. So I knew that if I could work out 1%, then I could find 100%. So I don't know whether you used a ratio chart, but it's really helpful because I can see here that in order to find 1%, I can divide that by 4. And if I divide that 4% by 4, I'm going to divide 14 kilometres because 14 kilometres is 4% of the long distance walk. So dividing by 4, I halved 14 and then I halved it again. So half of 14 is 7 and half of 7 is 3.5. And then I needed to multiply my 3.5 by 100. Well, I know that 3 times 100 is 300, so I know therefore that 3.5 multiplied by 100 equals 350 kilometres. That's like walking from London to Leeds, Mr. Kemp. That was incredibly long. Anyway, I hope you got on okay with that practice activity. Let's have a look at the learning in today's lesson. So in this lesson, we're going to look at a percentage reduction, where something has been reduced by a given percentage. You'll remember when Mrs. Chambers looked at where you might see percentages. And this was one example where you get sales in shops and items of clothing are reduced. In this lesson, we're going to look at where we're given the percentage reduction and we have to find the original number or value. So we have a coat, and in this case, all the clothes are now 10% off the full price. A coat has been reduced by 10%. And it's now £45. What was the original price? I think it would help if we drew a bar model to try and see the relationship between all of this information that we've been given. Pause the video now and see if you can have a go at drawing a bar model to see how £45 relates to the original price of the coat. Mr. Whitehead looked at bar models with you, and it helps us to see the relationship between the information that we've been given. So we know that the coat has 10% off in the sale and the price is now £45. Let's put that information in. So this bar is going to represent the 100% and it's been reduced by 10%. So if I subtract 10% of the original price, then I will be left with 90%. And I know that 90% of the original price is £45. Okay, pause the video now and see if you can use this bar model to work out what the price of the coat was before it had been reduced. Let's have a look at some solutions. We know that the coat has been reduced by 10%, and that's not a brilliant reduction. It's only a small amount that's been subtracted off the original price. So this person has found 10% of 45, which equals £4.50. Yep, that's correct. And then they have added that back on to £45, and they've got £49.50. So they've said that the original price was £49.50. That's here in their solution. Well, it kind of seems about right. The relationship between £49.50 and £45, that seems like it's about right. But I'm not quite sure. I think I'm going to have to come back to that. Let's have a look at another solution. So they've said that the original price was £450 and they've only paid £45. Well, the difference between 450 and £45, that doesn't look anything like a 10% reduction. So I think you're going to have to come back and unpick what this person has done. I think the solution is something else, and I think we're going to go through that together. Right, let's look at that original bar model and put in some more information. So we know that we had our coat and it was reduced by 10%. So I'm going to subtract 10% off the original price, and that's going to represent 90%, which is £45. That's the information that I've been given. And I had to work out, didn't I, that £45 represented 90% of the original price. If I draw another bar model underneath, it will help me to see the relationship between 90% and 10%. Here I've got 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So this is 100%, and I've got 10, 20, 30, 40, 50, 60, 70, 80, 90. I've got 9 lots of 10%. So £45 represents 90%. So to find 10%, I'll need to divide by 9. So what does this part here represent? It represents 10% of the original price, and 45 divided by 9 equals 5. Okay, I can use that to work out then the original price, because 10% add 90% equals 100%, and I know here that this is going to equal 5 because I've worked it out by drawing this information into this bar model. And if I know that 10% equals £5, 45 add 5 equals £50. I could also multiply 5 by 10, and 5 multiplied by 10 equals 50. 10 lots of 5 going across here equals 50. That really helps me to see the mathematics. But I wonder if you did it a different way. It doesn't matter how you draw your bar model as long as you understand what each number represents. Let's have a look at it on a double number line as well. So we know that the coat here has been reduced by 10%. So what's the missing percentage here underneath this rectangle? Yeah, you're right, it's 90%, because we know that we can work that out because of 100% subtract 10% is 90%. And if I know 90% of the original price is £45 from this information, I can work out another percentage that's going to help me, and 10% we know is a really useful percentage to work out. So to work out 10%, I'm going to divide by 9. So here I'm going to divide by 9 in order to work out 10% of the original price is £5. And if I know 10%, I can work out 100%, which is £50. I think I quite like the double number line in this case. I think it's really easy to see the relationships between the values. Let's have a look at it in a ratio chart. I know that the price is now £45, and I know that it's been reduced by 10%. So I need to work out what percentage of the original price the £45 is. And that's easy because I can do 100, subtract 10, and that will give me 90%. So £45 represents 90% of the original price. So in order to work out 10%, I'm going to divide by 9. So here I'm going to divide 90% by 9. And if I divide 90% by 9 to equal 10%, I'm going to divide 45 by 9. And then that 9 looks a bit dodgy. Okay, I'm going to divide that by 9, and that equals 5. And if I know 10%, I can use that to find 100%. I could multiply it by 10. 5 multiplied by 10 equals 50. I can also see that I could use addition. Remember with Miss Heaton, she said that if you've got known percentages, you can use those to work out unknown percentages. And here, 90% add 10% of the original price, £45 add £5 will give me the original price of £50. I've got two ways there of using my ratio chart. So we've got a ratio chart and we've got a solution here where we didn't know what percentage of the original price 45 represented until we'd worked it out. We worked it out as being 90%. And so 10% here is £5. We worked that out by working out what percentage the £45 represented. I think when you write it here, when you write it with equations, it's not quite so easy to see the mathematics. And when I've got my ratio chart, I think I prefer that to try and work out how I get the relationship. I wonder how you like to record your mathematical thinking. Go back to solution 1 and solution 2, because they were wrong. They'd got in a bit of a pickle. See if you can work out what they did. Because what we want to do in mathematics is to understand how mistakes are made so that we don't make them in the future. We've done this before, haven't we? So go back perhaps later after this lesson and have a little look to see how they got into such a pickle. Let's have a look at when a sale has 50% off the full price. Mrs. Chambers looked at this with you right at the beginning of this sequence of lessons on percentages. We've got a t-shirt here, and originally it was £8 before the sale, and then after the sale it costs £4 after the reduction had been made, and a pair of trousers that's half price and a hat that's half price. Can you see how I'm saying half price? That would be the same, wouldn't it, if a sale had 50% off the full price or if everything was half price. And a coat, 50% off. If you now pay £30, what was the original price? That's really easy, isn't it? It would have been £60. Let's put the information that we've been given onto our bar model and ratio chart. So I've got a bar that represents the original price. I pay £30, which is a 50% reduction. Well, if I reduce something by 50%, it also equals 50%. 50% of the original price equals £30. In order to work out the original price, well, I can just double that, can't I? Because two lots of 50% equals 100%, two halves equals 1, and that's going to equal £60. The original price was £60. So when you have a 50% off sale, the maths is much, much easier. But it's the same, it's just that you don't have to do that extra step because your reduction and what you actually pay, when you put that into a ratio chart, you don't have to do anything further apart from look at the relationship between the 50 and the 100 and how you're then going to double that to work out the 100%. Pause the video now and have a look at how 50% off in a sale is the same as half price. Let's have a look at another problem. A farmer sells 25% of her sheep and she has 600 sheep left. How many did she have to start with? So when I worked with my colleagues on planning this lesson, they said, Mrs. Lambert, I think you should draw a bar model. Apologies, it's not very funny. So here's my bar model, and that represents 100% of the sheep. She sells 25%. Okay, so I'm just going to think 25% is the same as 25 hundredths, which is the same as a quarter. So I've divided my bar model into 4 equal parts, and I know that I'm going to subtract one of those parts because 25%, 25 hundredths, 0.25, 1 quarter of the sheep have been sold. And I now know that this 600 is here. and that's 75% of the sheep. Okay, that's helped me to see the mathematics. I'm now going to have a look at it in a ratio chart. So here I know I've got 600. I don't know at this point what percentage of the original amount of sheep that she had this represents, but I know that she has sold 25%. And therefore I can work out that 600 sheep, that must represent 75% of the original amount of sheep that she had. How am I then going to use this information to work out 100%? Pause the video now and see if you can complete the ratio chart. Okay, I've put those values in and I'm going to see if you can explain how you worked out 25%. Yeah, I can hear you saying it now. You divided 75 by 3 because 75 divided by 3 equals 25. So 75% divided by 3 equals 25%. And therefore I'm going to divide 600 by 3 and that will equal 200. And then how did you go from the 200 to work out the 800? I just multiplied 200 by 4 because I knew that 25% represented 1/4. You could go back and look at the bar model to see that. And 200 multiplied by 4 equals 800. Ratio charts, as Mr. Whitehead said, are really helpful to work out some of these solutions to problems that we've not seen before. Let's have a go at finding some missing information. We've got a ratio chart here where we know that 40% of the original number equals 28. Pause the video now and work out the missing values, and then start it again and I'll go through it with you. So I'm looking at the relationship here between 40% and 10%. And I think that the obvious thing to do here is to divide by 4. And if I've divided 40% by 4 to equal 10%, I'm going to divide 28 by 4, and that's going to equal 7. And then once I've got this information that 10% of a number equals 7, I'm going to multiply it by 10 to equal 70. I could have added 28 and 7, and that would have given me 35, and that would have represented 50% of the number because 40% add 10% equals 50%, and double 35 equals 70. I've got lots of ways at finding missing information. Let's have a look at another ratio chart where there are some missing numbers. I'd like you to work out what 5% of the number was and therefore what 100% of the number was. Pause the video now and then I'll go through it with you. Okay, I looked at this relationship here and I could see that 15% had been divided by 3 to equal 5%. So I've divided 60 by 3 and that equals 20. Did you get that? Now I've got 5% and I've now got to find 100%. I wonder if you put in another row because that's what I'm going to do because I need to find 10% and I can double 5%. I can multiply it by 2 to find 10%. And so I'm going to multiply 20 by 2 and that will equal 40. And I know that 10% multiplied by 10 equals 100%. So if I go from 10% to 100%, I've multiplied it by 10. So 40 multiplied by 10. Have you got it? Yeah, it's 400. Ratio charts are all about that multiplicative relationship. And I know that if I've divided by 3 here, I need to divide this value by 3. And likewise, when I've multiplied by 2, I multiply this by 2. It's all coming back to me when I looked at equivalent fractions. It's a similar thing that's going on here with this particular ratio chart. We're right at the end of the lesson now, and I'm going to leave you with a question very similar to what Mr. Kemp went through in his lesson. I'm thinking of a number, and when you reduce my number by 30%, you get 490. What is my original number? And I'd also like to give you a challenge. I have a length of rope. I cut off 20% of the rope, and the remaining piece is 10 meters long. How long was the rope to start with? Use a bar model, use a double number line, or use a ratio chart. And because this is the last lesson, I'm going to go through the solutions at the end of this video. So make sure you have a go at the practice activity and this challenge before you carry on watching. Hope you have fun, and make sure you see the mathematics and really understand how you come up with your solutions. Explain it to somebody else. That's a really good way to help you with your mathematics. Okay, I hope you had a go at doing the practice activity before you watch this part of the video. Let's go through this question together. So I'm going to use a ratio chart, and I'm going to insert the information that I've been given. I know that the number, the original number, has been reduced by 30%. And I know that after that reduction, I get 490. So 100% subtract 30%, that equals 70%. So 70% of the original number equals 490. And then I'm going to use 70% of the original number to find 10%. So I need to divide 70%. I need to divide it by 7, and therefore I need to divide 490 by 7, and 49 divided by 7 equals 7. 49 tens divided by 7 equals 7 tens. 490 divided by 7 equals 70. Now I could work out 30% because if I know 10%, the relationship to work out 30% is I would multiply by 3. And 70 multiplied by 3 equals 210. And now I've got 70% and I've got 30%. I could just add these two numbers together to work out the original number, because if 70% of the original number equals 490 and 30% of the original number equals 210, the original number equals 490 plus 210, which equals 700. But I think you probably looked at this ratio chart and thought, if you know 10% equals 70, I can multiply that by 10, because 70 multiplied by 10 is easier than adding 490 and 210. The original number, the number that you were thinking of, was 700. I hope you got that and really understood how you presented your information, either in a bar model, a double number line, or a ratio chart. This one looked quite tricky, but I think because you have worked so hard and you have understood the use of the bar model, the double number line, and the ratio chart, you won't have got in a pickle at all. So I'm going to go through this quickly with you now. I've drawn a bar model to help me see the mathematics. So this represents the rope before anything was cut off it. And I cut off 20%, and the remaining piece is 10 meters. So that's 20%. And so I know that 10 meters is going to be 80% of the original length of rope. I'm going to draw another bar model now underneath to help me to see how I can work out 10%, because that would be helpful to work out 100%. So 10 meters, okay, 1, 2, 3, 4, 5, 6, 7, 8, 10, 20, 30, 40, 50, 60, 70, 80% of the original rope equals 10 meters. So I could divide I could divide 10 by 8. 10 divided by 8. What did you get for 10 divided by 8? Yeah, 10 divided by 8 equals 1.25 meters. So I can put those values in. 10% of the original rope is 1.25 meters. And then, in order to work out 100%, I could multiply 1.25 by 10, and 1.25 multiplied by 10 is 12.5. Or I could have added these two together to get 20%, and 1.25 add 1.25 is 2.5, and then I could have added 2.5 onto 10 meters, so it would equal 12.5 meters. I think there's a better bar model, so I'm going to show you that now. So you might have used a different bar model. I'm going to start off with the same one that I did on the previous example. So my original rope has been reduced by 20%, and I'm left with 10 meters, and I know that that represents 80% of the original rope. But because I can see that I've got 80% here, if I divide that by 4, that will equal 20%. And if I know 20%, then I can add it back on here because that's what I've reduced my original rope by. So I'm going to draw this bar model underneath, and I've divided my 80%, I've divided my 10 into 4 equal parts, and each of those parts represents 20% of the original rope. Did you do it that way? 20% of the original rope equals 10 divided by 4. And to divide by 4, I halve and halve again. So 10 meters, half of 10 meters equals 5 meters, and half of 5 meters equals 2.5 meters. And if I know 20%, I can just add that on to my 10 meters because here is 10 meters. And if I know that 20% of the original rope is 2.5, 10 add 2.5 equals 12.5. I wonder which way you did it. You might have drawn a ratio chart. These two ratio charts link to the two different bar models that I've just shown you. This one here shows you how you divided the 80%, you divided the 10 meters into 8 equal parts, and 10 divided by 8 equals 1.25, and then you use that to find the original length. And here I had 80% and I divided it by 4, and then once I'd found 20%, well then I could just add these two values together, or I could multiply 2.5 by 5. It doesn't matter which one you used. Let's think back to the start of this sequence of lessons. And you've made so many connections between fractions, decimals, and percentages. Remember that sometimes it's easier to use fractions, sometimes it's easier to use percentages, and sometimes it's easier to use decimals. If you know the equivalents, you can decide. Carry on making connections and make sure you really understand the mathematics. It's really good to be able to get answers, but that's just the beginning. Bye for now.